Okay. Now, here's our, this is the A matrix. We've used it several times. And I'm not going to read it to you. Right there's the A matrix multiplied by the X vector, which I specified to be the vector, column vector X, Y, Z. And that's equal to another vector, 5, 3, 1. Okay? So we're solving AX equals B, where X with the arrow over it indicates this is a vector, a column vector, and the B with an arrow over it indicates this column vector. We solve this by using the inverse matrix. Now, we did the inverse matrix in our preceding class, so I simply gave you the inverse matrix as we obtained it. Just to read these, the inverse matrix, this is 2/5, negative 3/10, 3/5, negative 2/5, 3/10, 2/5, 1/5, 1/10, negative 1/5. Okay, if we were to multiply both sides of this matrix by this, which is the inverse of the matrix A, then the inverse matrix times the matrix A would give us the identity matrix. The identity matrix times the XYZ vector just gives us the XYZ vector. So our left-hand side becomes this. Our right-hand side, of course, becomes the inverse matrix multiplied by whatever's on the right. So here's our inverse matrix times whatever's on the right. So this is our equation. X vector equals inverse matrix times our B vector. B vector here, inverse matrix here, X vector here. Now, I didn't multiply this out. You can multiply this out. Having multiplied this out, then we know what X is, we know what Y is, we know what Z is, because this product is going to give us a column vector with 3 numbers. You can then verify the original equation. Whatever 3 numbers we get here, if you put them in here, multiplying by this matrix will give you 5, 3, 1 B vector, if you do everything correctly. And this is a good way to check your matrix multiplication. It's a good exercise in matrix multiplication. Also reinforces the idea of how we solve a matrix equation. Okay? Now we want to talk about this. Again, this is really the same type of thing as what we did here. It's just that his is a 3 by 3 matrix. This was a 2 by 2 matrix. If we had a 4 by 4 matrix, we'd get the inverse matrix by writing down that 4 by 4 matrix and then augmenting it with the 4 by 4 identity matrix. Row reduce it, we get our inverse. It's a little bit of trouble. It's a number of steps, but compared to some of the things you might have to do with matrices if you didn't have more efficient methods, mostly related to row reduction, it's really quite simple. Okay, a little tedious, a little error prone, but inherently simple.